Alright, I am back, guys. Also, quick heads up. Literally, literally right before I started this, I was chilling down here, just having my snack, right? Just watching some OTT, and then on the corner of my ear, like, what is that music coming from? And then I opened my ears, like, I went upstairs. I'm like, why the crap is it so loud up there? And turns out, my dad went to the store and bought a speaker like this massive. I'm assuming it's for in here because he absolutely jams out to music and movies down here. Whatever. But, anyways, back to work. Also, if you're new and you have not, oops, sorry. If you're new and haven't seen my previous stream, go watch that if you want. Yeah, you can hear. You can hear it. I swear that boy. He's just screaming music. Yeah. Ignore. You can hear how loud it is. That's from upstairs. And I can't do anything about that. That's literally up those steps and in the kitchen. Which is like, oh. Alrighty, so. Ignore. And literally me and Killen went upstairs screaming like, turn it down! It was that loud. Down here and I like couldn't hear myself think. Alrighty. Where is it? No. Aha! Here it is. Ignore. Yeah, you can barely hear it. Whatever. Yeah, I think that's the only reason he left. If you guys were in the stream earlier, I left and checked. Yeah, you had to leave, but like, I have to question that boy at times. I'm serious.
Now we've added our player, our vehicle, and our obstacle to our scene, but now we really want to get a lens of our player and understand their perspective. So we can actually do that using our camera. If you go to the hierarchy on the left side of Unity, select your main camera by clicking on it, you can see that now we have the camera selected. This very large rectangle pops up, and on the bottom right, we can actually see our camera preview. In fact, if I deselect the camera, the preview goes away, and if I select
My
the
bad.
camera again, the preview comes
But
back.
accidentally
So
said,
the preview is actually what we
I'm
can
about to
see
go up
of
there
what the
and
player will see in
do
our game.
just
And in fact, that preview is entirely mapped to this
absolutely make him
huge
turn that thing
rectangle that we
off.
can see in our scene. And so this is very helpful to see and understand what the player sees. Our camera actually controls what we see in our game view. So, in fact, if I go to the top of Unity and I press the play button, you can see that our scene view changes to this view here, which is our
1 second, guys. I'll be right back. So, problem solved. Yeah, it's not actually going down here. He fixed it. He turned it down. But it's actually like $400 bigger plan for parties and all.
Our game view.
Good
In
gracious.
fact, in the center, the
He
two
has money to
tabs
burn.
are side by side right next to each other. So, in our game view, you can see that if I try and click on our vehicle here, nothing will happen. I can still select the vehicle in the hierarchy, however, nothing changes here. Versus if I go to my scene, you can see that our vehicle's back there. If I select the move tool, I can move our vehicle again. And then in the game view, you can see that our vehicle actually moved a little bit. So maybe if I go in the transform component, if I press like 5. Okay, cool. So the vehicle is moving. That's interesting. Now, the one thing about play mode is, so this is how we test how our different objects interact in our world, how our player can, for example, control our vehicle. Since I made changes to our vehicle in our scene view, in fact, if I press the play button again, so I stop the play mode, our vehicle actually moves back. Let's see if I can test that again. We'll go straight into the scene view this time by clicking on it, and I'll just move the vehicle back somewhere to like maybe like 10ish or so. And then I press play again. Our vehicle snaps backwards. So play mode doesn't actually save if we change anything about any of our objects. But our play mode and our game view is really helpful. So when we're testing out how our player actually plays and experiences the game, we can see that in the game view versus in our scene view, where we go to set up our objects, position our vehicles, move our obstacles in our scene, and interact with them that way to create a layout for our environment. So what you're going to do is you're going to go into your hierarchy, select your camera. You can see the camera. And then if you want to go into your play mode, you can press the play button and it'll go into your game view. In fact, you can use Control or Command P to actually exit play mode. And if you press that again, Control or Command and the P key, it'll go back in. And so you can see what your player will see when they're actually in the game. Now it's your turn. Watch me before you do this yourself. So, we've learned a little bit about the perspective of our player and what they can see and experience. We've added our vehicle and we've added our obstacle now. So, we're actually going to reposition our camera in our scene so that way we can actually get a better view behind our vehicle. So, what we're actually going to do is, instead of using our transform component on the right side, we're going to make sure we select our camera, and in the top left, you can see all of the different tools that we have. So for now, we're going to make sure that we have our move tool selected. It's those 4 arrows in those 4 different directions. So remember, control and hold, and then left click on the red arrow. And so we can move our camera on the x-axis here, and I want to get it to 0. Cool. And now I'm going to keep my mouse cursor in our scene view, and I'm going to press F to focus so I can shift the perspective again back onto our camera. Now I'm going to do the same thing with this blue arrow so I can move our camera behind our vehicle. So if I left click and press and hold our control key, I can move our camera back somewhere to around, say, there. And then the same thing with our Y. I will press the control key and hold and left click and drag. So we'll put it somewhere about there. Cool. So now our camera, if I focus back in by pressing the F, and then I'll reposition my camera of our scene view. Now, you can see that our camera, according to our preview, is just looking straight off the road. So that's not a helpful perspective at all. So we're going to reposition this camera this time with our rotate tool. So if you go to the top left of Unity, you can see this circle arrows. If I click on that, our rotate tool is selected. And now, in fact, you can see all of the different arrows have turned into lines, but these lines are actually well aligned to all of the different axes that we were playing around with before, so the X, the Y, and the Z. Now, to make it a little bit easier for us, I'm actually going to go to the top right of our scene view, and you can see this handy little gizmo over here with all of the different arrows. In fact, if I click on this green Y arrow here, you can see our perspective actually shifts to a top-down view from what we would see on the Y. And so I'm going to reposition back over the camera. So now I can very clearly see this green line, which will actually rotate around our Y-axis in this case. So if I click on the green line, I can rotate our camera by dragging it to the right or to the left. So I want to drag it, we'll say it's about there. And maybe I'll clean this up a bit later. So that's a good behind view. And now, in fact, I want to get a better perspective on our car. You can see it's not entirely in frame. So if I click on this opposite arrow of our Z arrow, this will actually, instead of bringing us to the front of our camera, this will put us behind our camera. And so now you can see we have a better view of our Z axis here. Actually, in fact, I want to go to the X, so I'm going to go to the side view, click that. There you go, better. So now you can see, we can see the Z axis, so this will actually rotate our camera up and down. If I click and hold on this, I can drag it down a little bit, and now we have a really good view of our vehicle. In terms of other tools that you can use to make it easier, so on the top left with all of our different tools, we have all the way on the left-hand side our hand tool. So in fact,
Okay, I'm back. He was screaming music at like 500% volume up there, to the point where it felt like the speaker was right here. Oh my gosh! Couldn't also turn on my mic because it was also religious music. Whatever.
in fact, if
'Cause I
we
didn't know.
select our
Ugh,
hand tool
YouTube would get mad at
and
me.
we left click and drag around our scene view, you can see actually this is very similar to just moving our scene view camera, or scene view perspective. The tool next to it that we were playing around with, that's our move tool, so we can move our camera or any of our objects in these three different directions. Let's see if I can get that X back. There you go. Cool. Now you can see all the different arrows. The tool next to that is our rotate tool, which we use to rotate our camera down towards the player. The tool next to that is actually our scale tool, which in this case wouldn't really do anything because we're on a camera. But if we were to select our obstacle or our vehicle, we could make our vehicle larger if we wanted to. The tool next to that is our rect tool. So this actually combines the move, rotate, and scale
If you can hear
tool
music, I'm
all in
sorry
one
about that.
tool.
That's my dad.
However, this is only very useful for 2D. In fact, if I select the vehicle, you can get a better view. There's this kind of rectangular outline around our vehicle. So useful for 2D. In this case, we have a 3D world, so that doesn't really help. If we select the last tool, all the way on the right side, this actually combines our move, rotate, and scale tool, and you can actually see all of them around our vehicle. So you can see the rotate tool around it, you can see the movement arrows. If you click on this gray box, you can scale your vehicle up and down. I don't want to do that though, so I'm just going to Control or Command Z to undo that all the way so it's back to normal size. So you can actually use this tool to control all the different aspects. Useful little tip to actually scroll through all of those. So if you actually just press the Q key on your keyboard, it'll select the hand tool. If you press the W key on your keyboard without doing anything, it'll select the move tool. If you select the E key, that's our rotate. If we use the R key, that's our scale. If we press the T key, that's our rect tool.
So that's actually very handy. On key, that's the QWERTY key layer. How much you want to bet the next one's gonna be Y?
And then if we press the Y key, that's all of our tools together.
That's handy.
For our 3D space. And then one last thing that we can do just to see and make sure that our main camera is set up properly, even though we can see it in our camera preview, is if we go into our game view again by pressing the play button at the top, you can see now our perspective has shifted from side view to behind our vehicle. So that's very helpful. So what you're going to do is you're going to select your main camera and you're going to move the camera behind our vehicle, and then you're going to use the rotate tool to rotate the vehicle into the frame of our camera. Now it's your turn.
Alrighty. Crap! Close the tab. Ah, great. And mine, cause Opera is handy. What's it like? Getting this all correct. He has one 18.75. I'm just gonna do 18. That looks pretty good, right? Alrighty. Customizing the interface layout.
So we've set up our camera, so now that we have a good perspective of what our
Yup.
player will see, we're going to play around with the actual Unity editor itself
Probably nothing
to
interesting.
rearrange some of our windows and make it easier for us to navigate.
I already did
So
that.
a really cool thing about Unity is you can actually reorganize all of these different little tabs that you see to clean up our project and make it a little bit more efficient for us. So in fact, for example, with our game view, if I left click on it and I drag it, it actually snaps out of the view that we're in. And I can put this wherever I really want. So I can put this underneath the scene, and then we can actually resize these windows. Or if I left click and drag the game again, I can drag it down to the bottom where our project window was and put it down there. So that's kind of cool. We can rearrange things however we want. Luckily, in Unity, we can actually just do all of these things with some preset options. So on the top right, all the way past the inspector, in the corner, you can see this little button that says default. So in fact, if I left click on that, and since I move things around, if I click on the default button again, it'll reset my entire editor experience to be back to what we had in the very beginning. And then if I click on the default option again, there's other options. So there's a 2x3, which is kind of cool. There's a 4 split. So this is kind of useful, especially if you're doing like a 2D game or something like that. There's a tall layout. And so this one puts our scene view and our game view side by side, which is kind of useful. We have a much larger view of what is happening.
Oh.
So I actually kind of like the tall view. So what I'm going to do is I'm going to rearrange some things a little bit. So I'm going to make our inspector just a bit smaller. So you see these lines between the windows. You can actually mouse over them. It turns into this little drag icon. And then you can click and drag our inspector. So I'll make that a bit smaller. I'm actually going to make our hierarchy and our project column a little bit smaller too. So I'll click and drag. Now our project window is kind of messy now. So what I could do is all the way at the bottom right of our project window, there's this little slider at the bottom. So this actually makes our icons larger. If I drag it to the right, if I drag it all the way to the left, it actually makes it smaller. So then I can like double click on these instead, and then it'll just create list views of what I can see. But I don't get those cool little previews of our little assets, unfortunately. And then it's still kind of narrow. If I had longer names, it'd be really hard to see. So in fact, I'm just going to turn this into one column entirely instead of having these two small columns. So in my project window, all the way on the right side, there's this tiny drop down. And if you're using a new version of Unity, you'll see 3 dots in a vertical line. So if I click on that, you can see there's a 2-column layout or there's a 1-column layout. So if I click on the 1 column, now it gets rid of my folder previews for what I can see inside my vehicles folder. So now instead, I just have to click on these little drop-down arrows, and then it shows me all of the different assets that I can use. Same thing with the obstacles. The nice thing too is it makes it a little bit easier if I collapse the vehicles folder, and then I can even collapse my course library. Now it like looks really clean, which is helpful. And then the last thing that I'm going to do is I'm going to left click and drag the game window, and I'm actually going to drag it to the bottom of our view, and it pops like that. Now one thing that might happen is, for example, if you actually drag it out of a space where there's anywhere it could snap to, it'll actually pop out like this, which can be helpful sometimes, but not entirely ideal. So you can actually just click on that tab again, drag it back, and then snap it in place. And now if we make this a bit larger, cool. Now we have a really good view of our game and our scene at the same time. So this is what we as the creator see versus what our player will see when they play the game. And then if we want to actually save this all the way on the right side back to where we set our layouts, if you click on that, at the bottom of the options is actually a save layout. So if I click on save layout, I can rename. So I'll call this my layout. So now I have my layout saved to use whenever I want. So that's super handy. So what you're going to do is you're going to click on my layout, and you can select one of the different layouts that you think is cool. In this case, I went with the tall layout, and then I dragged out by clicking on the game tab and then dragging it down to the bottom. Snapped it to the bottom of our scene view, so now we have both views together. I resized my inspector and my hierarchy just so there's more space. And then because our project window got a bit cluttered because it's pretty small down here, on the project window, all the way on the right side, you see this little drop down. If I click on that, there's an option to select one column layout. And so now all of our folders are just in these columns, and I can just expand them and collapse them to see what's inside. Now it's your turn.
Okay. So here's a little bit of actually customizability. I can actually customize this a bit, actually, like a lot. So this is simply just this is not like a set thing you have to follow. It's to your specifications. So we're actually gonna go ahead. I like 2x3, but we're gonna do what's wide. Actually, I like that. Other than the hierarchy, I love it. Here's what I think. I'm thinking the hierarchy. We'll move that up there. I love having this down here. Beautiful. And without doing single list. One column. We'll do it like that. Right there. Move that right there. Obviously, does not need to be as big. I just want this down just a tiny bit. You too. Shorten you down just a tiny bit. And I personally like having this scene in game. One, this is fine. And then we'll... Alright, that's pretty good. I like that. The how... wide, that's custom. Custom wide. That's fine. I'll be right back. I have to go bathroom real quick. Enjoy. Okay, I'm back, guys. Just some problems going on. We're all good though. Righty. Where are we? Oh yes. Complete.
Alright, so we've made it to the end of this lesson. As a recap, we've learned a lot of new functionality, so we got our first project set up and imported so that we can use all of the different assets available to us, like our obstacles or our vehicles. We learned how to position our objects, so in this case we have our vehicle at the origin of our world, and then we moved our box just a little bit down the road here. And we also learned how to position our camera and even used our rotation tool so that we have a better position and view of how our game will look to our player. We learned some new concepts and skills, like creating a new project, importing all of our assets, adding objects to our scene. We learned about the difference between our scene view for setting up our environment for our player and creating our stage versus our game view, which is what our players experience when they're in the game. We learned about all of the different windows, like our hierarchy or our project directory, our inspector, even moved them around and made our own custom layout. We learned how we can navigate around 3D space and all of the different tools that we can use to be able to interact with all of our different objects. In the next lesson, we'll make this project really interactive by writing our very first line of code in C# to make the vehicle move down this road and interact with our obstacle in the scene.
Finally.
We'll see you in the next lesson.
Oh, that was boring. That was boring as ever. Alrighty. Well, guys, that's lesson 1. Let's see here. Type of imports, correct. Let's see here. Do I actually know this well? Type of assets imported, yes. Yes. Yeah. Oh, wait. Okay, well, I could be learning C#, okay. Too easy, I should say.
Now watch and pay attention before you do this yourself. We have our layout set up nicely here in Unity, so everything is nice and organized. We have our scene set up. So now we're actually going to create our very first C# script to be able to control this vehicle's movement. In order to do that, we're going to go to our project window and then make sure you right-click on the assets folder. And then you're going to go to the create button and we're going to create a new folder. We're going to name this folder scripts because this will actually be holding all of the scripts that we'll use to manage all of the interactions in our game. Now, it's very important, especially as you start a project, to keep all of your different folders organized so that way it's easier to find all of the different things that you need, whether it's your assets that you're using in your scene, like in our course library, or different scenes that we need to manage, or in this case, our scripts, so that way we know where all of our programming is being done. Now, what we're going to do, we're going to make sure it gets added to the scripts folder, so we right-click over our scripts folder, and we create a C# script. Now we're going to name this script player controller, capital P, player, capital C, no spaces, controller. Now, when we press enter, Unity will automatically create this script for us, and we can actually preview it on the side. So you might be wondering to yourself, why did we capitalize the P and the C, and why are there no spaces? Well, this is actually something called a naming convention, and this is just a standard thing that developers do and people do when they're creating their projects as a way to make it easier for other people to jump into somebody else's project. So if somebody were to play around in your Unity project, they could understand the scripts and all the things that they're supposed to do and what they are. So capital letters for each word in a script makes it really easy for people to know that what you have is a script right there. Another reason to name scripts up front is because it can actually create a pretty large problem in Unity. So what I'm going to do is on my scripts folder, if I right click on it and I click create C# script, and I don't know what to name this script for now, so I'm just going to call it test. And so here you can see that the test script is created, and you can see that it's previewed over in the inspector. Now, say later down the line, I want this to do something. I don't know, maybe for some reason I want to make the obstacle fly or something like that. And then I press enter. So we've renamed this script to be obstacle fly, but in our inspector, you can see the preview of our script. It's still called test, even though we just changed it. So this could actually potentially break things in your project and create conflicts between the name of what you have in Unity and the name of your script. And so it's just better to name everything up front, name it exactly what you want it to do, and make sure that you use the standard naming convention so that way it's easier if other people have to jump into your projects. So I'm going to just right click on obstacle fly, and I'm going to delete this from my scripts folder because we don't need it. So we have our player controller script now, and we're going to left click and drag it onto our vehicle. And now, if I click on my vehicle, you should see on the right side in the inspector that there's a player controller script that's been added to our vehicle. Now, scripts are the way that we're going to actually create all of these different interactions for any of our obstacles, our vehicles, even our camera in our environment. And so when we want something to do something, we need to use scripts to be able to tell Unity what we want that thing to do. In this case, our player controller script will make it so we can actually move our vehicle and control it. In addition, when we dragged our player controller script onto our vehicle, you can see that it was added here in the inspector, and so it was added to our list of different components. And so our components are basically the different properties that we can see attached to all of the objects in our scene. So, for example, our vehicle has our transform, so it can control the position in the world, how it's rotated and oriented, the scale. We added our player controller script, so we know that we're going to create a behavior for this vehicle. And then there's other things too, like mesh renderers and mesh colliders, both of which we'll get into later. A mesh renderer just helps to actually enable Unity to show you the vehicle with all of these textures applied onto it. And the collider will actually be something we use later so that we can have our vehicle run into our obstacle. Now, for example, if we went onto our obstacle and we accidentally added our player controller, which we can also do by left-clicking and dragging onto our inspector if the selected object is highlighted, we can add it that way, but I don't want the player controller on this obstacle, so I can click this gear icon next to it, and we can actually remove that component. Or if I wanted to add a component another way, I could also click the Add Component button, and you can actually see all the different components that you could use if you ever wanted to, or you can just type in the name, so we have that player controller, added it there, but we don't want it on our obstacle at all, so we're just going to click on the gear, remove that specific component, we're good to go. So what you're going to do is you're going to right click on your assets folder, create a new folder, name that folder scripts, so that way we can see where all of our scripts in our game are being managed and organized. On the scripts folder, you're going to right click directly onto it and create a C# script, which you will name player controller, capital P, no space, capital C, and then you're going to add the player controller script either by left clicking and dragging it and dropping it onto our vehicle, Or if you select the vehicle by clicking on it, you'll see it pop open in the inspector. You can left click and drag the player controller into the list of components. Or if you have your vehicle selected, you can click on the add component button. You can type in the search bar and type in player, and that'll pop open your player controller script that you can see here, and you can add it that way. Now it's your turn.
Alrighty. Now I'm getting to territory that is unknown to me. Alright, let's do this. So, first things first. We're gonna go in here. Right click. Create a folder. We're gonna name it scripts. Luckily I fixed my R key. Create C# script and name it PLAYERCONTROLLER. Alrighty. Alrighty. Now it's looking. Now the next episode is going to be having me go into unknown territory, like very unknown territory. I didn't comment in the Oh, never mind.
We've created a scripts folder, and we've created our first C# script, and we've applied it to our vehicle as a component. And now we're actually going to get familiar with our script and the structure of it before we write any of our code
Nice.
inside of it. So make sure that in your assets folder you have it expanded, and then you open up your scripts folder by expanding it. And then if you double click on the player controller script, now you can see that my script has opened up in my IDE, which stands for an Integrated Development Environment. And basically, an IDE enables us to actually interact with our code and write lines of code and text inside of it. So you can actually see there's words that you would be very familiar with, like words like using and public and class. And so very similar to how you would write a note or write a essay in a text document, our IDEs enable us to actually write for our programs. So I'm just going to clean mine up a little bit. There's a whole bunch of information here that's not entirely necessary, so I'm actually going to go on my IDE, close this little Solution Explorer. I don't really need that. I don't need the Team Explorer either. I don't need the properties. Cool, so now I have a full screen. I'm going to make this a little bit larger. It's just a little hard to see. So on the bottom left, I have this little zoom option. So I'll set this to 200. It's pretty good. Now, my IDE is set to Visual Studio. That's actually the default that you would get downloaded on Unity. If not, you can always go to the website to go download Visual Studio from Microsoft. You might also notice that some of the colors are very different. Maybe you have a white background. That's just a setting of mine. I just turned my settings to be a dark background. I use some different colors for words because it helps make it easier for me to see. So you can change those settings on your own, or if you're using a different IDE, then you should be able to customize it in your own ways. But if you download Unity for the first time, you will download Visual Studio. Now, if we take a look at our class, I mentioned it before, but you can see all these words that are very familiar to you. Words like using, words like public and class. And a really helpful thing about an IDE is that in my case, it actually highlights certain words that are very important for a person and a computer to understand. So the different words that are actually highlighted in blue are standard keywords that your computer is made to understand. With our script itself, our player controller, you can see the name that we made before, and in fact, there's this weird colon icon. And so that icon actually means that this player controller inherits from another class called monobehavior. And monobehavior is actually a class that's applied to all the different objects that we create. So actually, if we made a script for our obstacle, it would also use things from monobehavior. And that's very helpful because in monobehavior, a lot of different things that we would need to write ourselves are already made in Unity. So it's really helpful and really easy to get started. For example, we have these two methods here, and you can tell they're methods because they have the word void, and then they have these parentheses, and then they have these curly brackets. So this usually tells you that this is a method statement, and here's actually where we can go write in some code if we wanted to. So start is a method that, as you can see, actually has a comment up here that is called before the first frame update. So when you press play on your game, it would call the start method. Versus the update method, another method from monobehavior. And update is called once per frame. So this is actually constantly checking in your game for different calculations it should make, or different things that it should be checking against if you have a box that collides with something else or something like that. And the difference here, you can see, so these two / marks actually create a comment, and your computer will not read what is on this line of code. So comments are for the purpose of a person to understand what they're reading inside of a method, versus the methods are actually the pieces of information that your computer needs to run certain tasks. So now, in our update method, we're going to write our very own comment. So make sure that you have your text selection inside of the update method. And then if you write / 2 / marks, we can say we'll move the vehicle forward. And so now this is where we're going to write our line of code to move the vehicle forward. But for now, we're just going to make a note for ourselves that this is where we're going to do it. So what you're going to do is you're going to double click on your player controller script, and then your player controller script should open in the integrated development environment, or IDE, that was set by Unity. And then in your player controller script, down in this section of code here, right after public class player controller, you can see all of the different methods that are automatically added by Unity. And specifically in our update method, we'll write a comment using 2 / marks so that we can tell ourselves that this is where we'll write code to move the vehicle forward. Now it's your turn.
Alrighty, this actually did not get into territory I already know. I already knew like comments and all that. Alrighty. Double click on the script to open it in Visual Studio. Ah, 1 second, guys. Be real. Give me 1 second, please. Alright, my bad. Do I not have to do the studio? Oh, yeah, let's wait for that. While that does its thing, I'm gonna bathroom real quick. Wait. I'm gonna bathroom real quick. Wait. I can wait. This just a VSC. It automatically does it. And we're gonna do right click, pin. I'm gonna close that and go back real quick. BRB. And I am back. Alright. Alright on up. Right on up. Alrighty. So, now we're in. Backslash, backslash. Done.
We've opened up our player controller script, and so now we can see all of this code that's inside of this script. And so we'll actually write our own line of code so that we can make the vehicle move forward from our little note we made for ourselves before. Make sure you pay attention before you do this. So what we're going to do is we're going to write our very first line of code here in our update method. So if I select this text block right after the word forward, if I press enter, so this creates a new line. So in programming, a blank space doesn't matter. Our computer just knows that there's nothing there. And what we're going to do is we're going to program using a programming language called C#. So everything that's done in Unity uses C#. If you're going to make a mobile application or if you're going to make a website, there are other languages that you can use to create those different kinds of applications, but for our game, we use C#. And C# is just one way that we're able to communicate directly with our computer using certain words that a computer is able to understand to do something that we want it to do. So in this case, we're going to write a line of code to move our vehicle. Now, what I'm going to do is I want to help visualize moving this vehicle down the road. So if I actually select the vehicle in my project hierarchy, so now you can see it's selected. If I left click on this blue arrow, I want to move the vehicle down the road. You can see down in the game screen. That's exactly what I'm trying to do. In fact, if you look in the inspector on the right side, as I'm moving this blue arrow in our transform component, you can see that the Z is actually updating. And so that gives us a really good hint of what we're trying to accomplish. So if you remember, our transform component was the thing that was updating as we moved that vehicle in the scene. In fact, we can actually use the transform component directly. So if I just type in transform, and in this case, lowercase versus capital case T is extremely important. They're two very different things. The transform is actually an entire class, very similar to our player controller class that has even more methods inside of it. A lowercase t means we're getting the transform component of our current object. In this case, it's going to be our vehicle. So now that we're getting our vehicle's transform, what we actually want to do is we want to move that vehicle in that Z direction. So we can use a method using a dot. So a dot will help us get methods out of our different classes and objects. So dot translate. And so you can see here this is a capital T because this is a method just like our update method. And so what is happening here is we're telling our computer we want it to do a specific instruction using this translate method. We want to translate the position, we want to change the position of our vehicle using its transform property. Now, to tell the computer that we're trying to make it do a task, we need to use these parentheses. And a really handy thing that my IDE does it is actually suggests different things that I can do and can autocomplete certain statements that I make if I'm trying to write code or if I'm trying to use a method. In this case, it's suggesting different things I can do with our transform.translate. So this here you can see inside of translate, there's a vector3 translation. So this is a parameter. This is a piece of information that I tell the computer to use to be able to do the thing that I want it to do. Now, I don't necessarily know what a vector3 is right now. So let's see if there's other options. You can see there's 6 total options. And this one seems to be really useful. So this one actually says that it will move the transform. It'll change that position by the X, by the Y, and by the Z. If you remember, I was trying to move my vehicle on the Z. So what I can do is I don't want my vehicle to move in the X direction. I don't want it to move left or right, so I'll just type in 0. I don't want my vehicle to move up or down. It's not a plane or a spaceship, so that's also 0. But I do want to move it in the Z direction, so I'm going to make that 1. Now that we've added our parameters to our method and we have that closed parentheses, we actually now need to add a semicolon. And so the semicolon actually tells your script that the method is now complete. So you can think of how we use periods to end our sentences and close our statements. When you're programming in C#, you use a semicolon at the end of your method to tell the script that this is the end of this line. So now what this will do is update is called 50 to 60 times every second. So in a second, our vehicle will move 60 units, 60 meters in a certain direction. So now if I test this in Unity, when I press play, I should see nothing. Okay, that's not what we wanted to happen. Let's see. Get out of play mode. What did I do wrong? So let me just player controller. Oh, I forgot to save. So you can see in our project window, I selected our player controller script, and it looks exactly like how we left it when we first opened it. There was no information inside of it. But as you can see in our script here, we've added 2 lines in here. We've added a comment, and we've added this method that we created. So the problem is we didn't save. Simple as that. So if you just press Control or Command S, now our script is saved. You can see now in Unity, in our inspector for the preview of our script, we can see those lines of code now. So now when I press play, I should see the vehicle move. There it goes, speeding all the way off the runway. And it's flying off into space. Maybe it is a spaceship. Cool. So we've written our first line of code to move our vehicle. So what you're going to do is in your player controller script, underneath your update method, inside of your update method, underneath the comment, you're going to write transform.translate, and then you're going to use an open parentheses, type a 0, 0, 1, close parentheses, and then semicolon. Now it's your turn. Our vehicle now moves virtually at the speed of light, just flies straight down our screen. So that's good. We've got the movement in. Now I just want to highlight some things with coding to make our lives a little bit easier. So, with our player controller script open
With
in
my
our
microphone also
IDE,
crap.
my IDE does some really useful things to make my life
Trying
a
to mess with
lot
some
easier.
variable.
So, one of the big things first is if I start typing a word, say transform, it automatically tries to suggest the word that I'm trying to type, in this case transform, and I can press enter, and it'll complete that word for me. Now, if I type dot or period or full stop, you'll see that my IDE suggests all of these different words. And a lot of these words, especially if they have this little purple icon next to it, these are all actually other methods that I can use, just like our translate method. Now you might hear people say methods or functions in Unity and in C#. They're essentially the same thing, but a lot of people just tend to call things methods when you're using these kinds of statements here that have parentheses. Now, you can think of all of these different words very similar to how you would think of a dictionary. And so a dictionary helps you understand a word that you're looking for. In this case, in programming, this is called documentation. And so our documentation, or our dictionary, tells us all of the different words, all of the different actions that we can perform with our transform component here. So I'll use translate again. And now, if we push that dictionary analogy even further, so we have the word translate. And if I use an open parentheses, you'll see that now my IDE suggests different parameters, different pieces of information that I can tell it to use to do something. You can think of this very similar to a thesaurus and synonyms, where many different words have a similar meaning. In this case, we have many different kinds of methods, and these methods all have different ways that you can essentially do the same thing. So in this case, it's asking for a vector3 translation. Now, in order to get a vector3, I can actually just type vector3. And here, now, you can actually see we actually have a suggestion as to what a vector3 is, which is super helpful. So my IDE tells me that a vector3 is a representation of 3D vectors and points. What does that mean? Well, in fact, that 0, 0, 1 is just 3 dimensions of points, 3 different points that we use, a 0, and a 1. In fact, that 0, and that 1 all correlate to the position on our transform component. So we have the 0 on the x, the 0 on the y, and then our 1 is actually the z updating over time. We even have these vectors, these 3D points, in our obstacle with our position. You can see the 0, 0, and the 25. That's a vector 3. That's 3 different points that we're storing. So with that information, it's very helpful because we can actually just shorthand this bit of code that we wrote with 0, 0, 1. In fact, if we use dot and then forward, you can see that forward is actually just shorthand for writing 0, 0, 1. So that actually, can save us a lot of time, and especially is very helpful to making our code easier to understand. Because if I told a person to move something 0, 0, 1, they'd be like, I don't know what you're talking about. But if I tell them to move forward, they know the direction of forward. So this is how different keywords in programming can help make our lives easier, to make it easier to understand what is in front of us, but then also translate that into something that the computer can understand, in this case, the 0, 0, 1. So if we remove now our previous line of code, now we'll just make sure that we save. Always make sure you save before you go back into Unity. And now, in our player controller, you can see that our translate method has changed from 0, 0, 1 to this vector3 forward. And when I press play, our vehicle is still flying all the way off the screen. So, looks like our code did exactly what we wanted to do before, which is great. And it's easier to read. So what you're going to do in your player controller script, you're going to change your line of code from 0, 0, 1 to vector3 dot forward. Now it's your turn.
Alrighty. Simple as doing. Which will work exactly the same. Yep. Just, and it's off. Exactly the same. Next.
We've fixed our vehicle, so now it flies down the screen once again, extremely fast. At least our code is a bit more readable, but now we need to slow that vehicle down so it doesn't just fly off into the distance. So in our player controller script, we're actually going to use a little bit of math in this method to be able to slow our vehicle down. So first what we're going to do is we're going to want to change the way that we move our vehicle. So currently the way this works is our update method is called every single frame. But depending on how powerful your computer is, you might get 20 frames in 1 second, you might get 60 frames in 1 second, and so really your player could move at varying speeds depending on what kind of device they're using. So we actually want to change that from updating every frame to updating over time every second. So the way that we do that first is by multiplying, and for a computer, you should use the star symbol. So if you press shift on your 8 key, it'll create that star symbol. Because actually, if you press X and use the X key, it considers that an actual letter that it needs to know to use for a word. So we use the star symbol to tell us that we're multiplying something. And then what we'll actually do is we have a class already made to keep track of time, so we don't have to write a class ourselves. So that is called time with a capital T, and you can even see it highlights it in green. That way we know that this was a pre-made class. So now we're using time to keep track of our time, and we actually use delta time to get the change in time between all of our different frames. So now, using this bit of code, we can actually know when 1 second has actually elapsed versus 20 frames happening, 60 frames happening, who knows, we can't control that. We can control how much time is actually passing. So if we go test this, we press play, and our vehicle is still flying down the road, and that's not what I wanted to happen. I forgot to save again. Okay, so back in the player controller, just make sure you save Control or Command S. That way it always updates the script in Unity. So now, when I press play, we should see our vehicle moving, albeit very slowly, but because of that little bit of code we added, we're actually now moving 1 meter a second. You can see, if you want to time it, it would probably be just about 1 unit every single second. So, cool. Now we have our vehicle moving by time. Granted, it's moving very slow, but we can fix that pretty easily. So what we're going to do in our player controller, we're just going to multiply by a random number using that star symbol. So we'll multiply by, say, 20. So it should move about 20 meters every second now. So now if I test and I press play, and I forgot to save again. Always remember to save. Now when we press play, there you go. Now it's moving nowhere near as fast as before, but definitely not as slow either, which is great. As a fun little tidbit, the way that this formula actually works, this little equation that we have, So in fact, vector 3.forward is storing a 0, a 0, and a 1. And so when you're actually multiplying it by the time and by 20, you're actually multiplying each of the different values. So first you multiply your 0 by time and by 20, which will always be 0. Then you multiply your y, which is 0, by time and 20, which is still 0. And then you multiply the z by time and by 20, which gets you 20 meters a second. So just a fun way to kind of see how the math works, and would definitely save a lot.
Okay, basically breaking it down. Time.delta time equals, so basically it's every second. So basically it makes, instead of it going every time, it multiplies it. Basically gives an output that if you multiply it by something that's happening every frame, it will change it so that it happens once a frame. Basically it's like one a frame, and then it just multiplies it by 20.
A lot more time than just typing 0 times time dot delta time times 20, comma 0 times time dot delta time times 20 times 1 times time dot delta time times 20. So a really helpful way that, especially this shorthand, makes our lives even easier than before. So what you're going to do is, in your update method, you're going to change your transform.translate to just include a star symbol for multiply, and you're going to multiply your vector 3.forward by time.delta time, and then you're going to multiply all of that by 20, so now it should move just about 20 meters a second, so that when you test your game, you press play. If you select the vehicle while it's moving, you can see the Z value changing, and if you used a stopwatch, I'm sure you could see that it probably moves just about 20 times every second. So, now it's your turn.
Alrighty, that's easy. Actually, yeah, I don't even do a bad luck. Okay, you go in here. Space times space time dot DOTA time TR. T fine. Yeah, capital T. Yeah, and if I go on the, if I look on here, yeah, capital T. Foot in time, both. Ignore me. Add rigid body components to objects. Oh, this is easy.
Our vehicle now speeds along at a normal rate instead of incredibly fast or incredibly slow. And now we want it so that we, instead of just driving straight through this box, actually can collide with it. In order to simulate physics in our world, we actually need to add something to both our obstacle and our vehicle. And we'll do that using our components. So our component system can add a lot of different properties that people regularly use. In this case, a property that people will commonly use for physics is a rigid body, which is a physics concept, and in this case allows us to interact with this truck here that we have as if it had real simulated physics on it. So now it's a solid object. You can see that on the rigid body component in our inspector. It has a mass, so we can actually make this heavier. We can use gravity or we cannot use gravity. So there's all of these different options. In fact, I think our inspector is getting a little bit too crowded, so you can actually click on the little arrows next to all of the component names, and it will compress down each of the different options. So that's certainly very handy if you have a lot of different components. So now we can see our rigid body component, which is great. And then on our obstacle, we can also go and with our obstacle selected in the inspector, we click add component. If we type in rigid body again, we can add another rigid body. So now our obstacle and our vehicle both have rigid bodies, which means they're both using physics, they both have mass, they both use gravity. So that's really helpful. And then one other important component to note in our list of components in our obstacle and our vehicle is actually these mesh colliders that we have on both of our objects. And our colliders are basically our ways of telling our simulated world that these objects can be collided with. So it knows that because there's a collider on this, when it runs into something like the ground or when it runs into something like our vehicle, it should do something like make it stop because we have a rigid body on it. So if we actually press play, you can see our vehicle collides with our crate, it goes flying off. If we were to turn any one of these things off, so for example on our obstacle, if we turn off our mesh collider, our box actually just flies straight through the ground, and that's because our mesh collider is telling our game world that the box no longer collides with our road, so therefore it can just fly straight through because it's not supposed to collide. So really fun things that you can do, and just to kind of make our little driving game simulation a bit more realistic, we're going to increase the masses of these two objects just to make it a bit more fun, make it interesting. So we'll make our obstacle, our little crate, maybe about 20 kilograms or so. And then the mass of our vehicles, I don't know, maybe something like 1,000. So now this has even more weight behind it, so when it hits that box, you see a slightly different effect happen. Yep, see? So took much longer for that crate to fly over the vehicle because it was much heavier. So, fun little things you can do to create better simulated worlds in your games using things like colliders to tell your objects to know when they've collided with something like our vehicle and our box, or even our box and our road. Using rigid bodies to be able to create physics on our objects, so that way our obstacle actually has weight, our vehicle has weight, and we're using gravity, so it's actually being pushed down into the ground at all times. So what you're going to do is on your vehicle, you're going to select it in your hierarchy, and you're going to go into the inspector on the right side, click add component, and you're going to add a rigid body. And then the same thing you'll do with your obstacle, select it in the hierarchy, go to the inspector, click add component, and then make sure you either search for or select the rigid body component out of the list. So you can do that either by going to add component, going to physics, and then you can see all of the different options like the rigid body, or you can just type in rigid body, and there it is. Super easy. Now it's your turn.
1 second. Let it sit right there. Done.
We've got some physics in our scene now, and we've got collisions happening, so as our vehicle's driving the road, it runs into this box goes flying, and now we're going to make this road just a little bit more treacherous, make our game a bit more difficult for our player by adding some more boxes. Make sure you pay attention before you do this yourself. Now what we're going to do is we're actually going to select the obstacle, and I'm just going to make this a little bit easier for myself, so I'm going to left click and drag the obstacle in our hierarchy and drag it all the way to the bottom of this list. So you see this little blue line underneath all of the other list of objects. And if we let go, now you can see our obstacles there. And now what I want to do is I need more boxes in this scene. So I'm going to select the obstacle in the hierarchy by clicking on it. And I'm actually just going to press the Control key and the D key at the same time. So if I Control D on our obstacle, it immediately duplicates our obstacle. And now we have another. And you can see if I hover my mouse over the scene and I press F to focus, it's directly on top of the other box. So that's not what we want. But we'll just move this one a little bit farther back. We'll try and get it to around 50 or so. I'm just going to estimate. Yeah, around there is good. 50.1, almost had it. Now we have a second obstacle. We want to add more.
Click on the box. Go into here. Type put a 5 after the 0. So hard.
So if I just keep duplicating and dragging, that'll take a long time. So I can actually do something to make this a bit faster. So if I select my first obstacle and I control click on my second obstacle, now if I control D, it creates 2 more obstacles. And in fact, I can move these back even further, just about, let's call it like there. That's good. We'll shift my perspective, so I'll actually click the little green Y in our scene view. Now we have a top-down view. And now I'm going to zoom out, so we're going to Alt and we're going to right-click and drag it to the side all the way to the left, so we zoom out even more. And now we can see, maybe hand tool might be useful for this. So I press Q, select my hand tool, there you go, so you can see more of the road now. Actually, it might help if I just turn. There you go. And then just zoom in a little bit. Perfect. Cool. Now we can see our road even better. Really good opportunity to test out your movement skills and see if you can navigate your scene. So now we have our 2 boxes. Now we're going to make another set. So now I'll select my first obstacle. And in fact, if I just hover over the last obstacle, I press Shift and left click at the same time. Now all 4 are highlighted. Now if I control D to duplicate, I have 4 more obstacles. Now if I select my move tool, I can move all 4 obstacles down the line. Somewhere like there. Cool. You can see this last obstacle, obstacle 7, is a little bit off the road, so we'll just delete that. So I'm just actually going to press the delete key on my keyboard, and it deletes it from the scene. So now we'll save really quick, and when I press play, you can see the vehicle drives, hits one of the boxes, 2, 3, 4, all the way down. You can see them tumbling down in the game view. So, up there the vehicle goes straight down. Oh no, can we catch it? No, it's gone forever. Well, we know the physics works now, so that's great. And we hit all the obstacles, and we've made even more, so we've made things just a bit more difficult. So what you're going to do is you're going to take your first obstacle, you're going to use Control D to duplicate it, move it down the road, just using the Z axis, this blue arrow on your move tool. And then you can actually select your first obstacle and control click on your second obstacle. And then when you Control D, it'll actually duplicate 2 more obstacles. So then you can move those down the line. And then you can actually just select your first obstacle and then shift click on the latest obstacle you made to select all 4 obstacles, and you can drag those all the way down the line. And then you can test your game out. Now it's your turn.
So, we need to duplicate it to 7 of them. What I'm actually going to do is this. Actually, let's do something. This. Boop. Boop. Simply do that. And then we do this. We control D. That's evenly spaced out 25 blocks. Evenly spaced out. 25. So, vehicles at 0, right? 0, 25, 50, 35, 100, 125, 120, 150, 175. I actually want to do, because this is a bit cluttered up. Don't tell me this, but I'm just going to create a... There we go. All of them are in there now.
So we've made it to the end of this little lesson. To wrap everything up, we've added some really good functionality to our game now. So when I press play, see the vehicle drives down the road. It doesn't move incredibly fast. It moves at a nice normal speed. It runs into all of these boxes with physics. Because the vehicle has physics, it just drives straight off the road, which is totally okay. Be free, vehicle. We also learned a lot about coding in this lesson. We created our very first C# script, learned a little bit about the structure of how scripts and classes work. We learned about comments, even made a few of our own, learned about methods.
Few mean one.
We wrote our very first line of code and called our first method to be able to move the vehicle forward. So now we know how to use methods. We've learned a bit about parameters and how we can pass computer the information that we need to do something. We even cleaned up the way our speed is calculated a lot by making sure that our vehicle moves over time instead of once every frame. And we even learned about these cool little multiply operators. And then on our vehicles and on our obstacles, we added a rigid body component. We learned a little bit about our rigid bodies and our colliders. So now we can really create collisions for our vehicle and our obstacles. In the next lesson, we'll add some code to our camera so that we can actually follow along behind our vehicle as it drives away down the road. We'll see you there.
Nice.
We've successfully programmed the vehicle to drive down the road, colliding with obstacles as it goes. But the poor player is left behind, missing all the action. So by the end of this lesson, the camera will follow the vehicle down the road, giving the player a front row seat to the wreckage. In order to keep the camera behind the vehicle, we have to understand a fundamental new programming concept: variables. A variable is just a piece of information that can vary or change. And variables are critical for what we're trying to do here. Since the vehicle's position will always be changing or varying, we need a variable to track that position. You couldn't set the camera's position to a fixed number like 5, 10, or 100. It wouldn't be able to move with the car. So we'll make a new variable for the vehicle's position, set the camera's position based on that variable, and just like that, your camera will be able to stay right on your vehicle's tail. To make all that happen, I'll see you in Unity.
Our vehicle now can drive all the way down the road. We have all these obstacles that they can collide with. It has a whole bunch of physics applied to it, but our vehicle still moves a little bit fast, so we want to be able to change it, and we also want to be able to see it. To do that, we're going to use something called a variable. So, in our player controller script, right underneath this first curly brace, underneath player controller, we're going to create a new line by pressing enter, and then on that new line, we're going to create our very first variable. So we're actually going to use this variable to be able to change this number here. So usually in code, it's pretty bad, especially when you have what's called a hard-coded number, because that means that if you ever need to change it, say we reuse speed for some reason ever again, we'd have to keep changing the number 20, versus we could just change the number in our variable. So what we're going to do is we're going to use the word float. Now, float is a keyword that helps the computer know that we're creating a number with decimals in it. And then we're actually going to say what the name of this variable is. So we can call it speed. And we're going to use the equal sign here. Now, it's very important. The equal sign to your code is very different than an equal sign when you're doing math in the real world. So this actually will assign our speed variable a value. So our speed will be set to whatever number we put next, and it will store that number whenever we need it. So because we are using decimals, we'll type a 5.0, so this is a decimal, and then we add a semicolon at the end, so that way we know we're at the end of this line. We are done with our statement. Now you can see that our IDE is pretty mad at us right now. There's this red underline, and it says that it doesn't understand what this 5.0 means. So actually what we need to do is we need to tell our program that this is a float, and so we add the F at the end. So now, as our computer tries to understand this line of code, now our computer knows that 5.0 is supposed to be a float specifically, so we add that F at the end. So now we have our speed variable. It's always carrying the number 5. If we ever need to, we can change it to be 10 or 20, whatever we want it to be. And so where we have our 20 in our update method, where we're transform.translating our object, we'll take out our 20 and just put speed. So now our code knows that we are multiplying by the value 5, even though we're using the word speed. So that's very helpful. So now, if we test our game, our vehicle should be moving a little slower. Not bad, so it's moving about 5 meters a second, and now it's just pushing those boxes along. Now, we want to actually be able to see this speed variable in Unity. So right now,
Public.
our speed variable
Calling right now. Public
is
float
a variable that
float
belongs
speed.
to this entire class. It's what we call a member variable. And right now, it can only be seen inside of methods inside of this class, and it can't be used outside of this class. Now, we can actually use the word private to denote the level of access that somebody has with our speed variable. The private keyword is what's called an access modifier. In fact, the public keyword is also an access modifier. So private can only be accessed within this class. In fact, this start and update method are both inherently private, so you don't actually need to type the word private. Versus the word public means that you can access, you can see, you can use this class in other places. So in fact, we want to be able to see and interact with our speed variable. So we will actually make this a public variable. So now that we've used the public keyword to modify its access, we should be able to see it in Unity. Now, a cool thing that happens when we go into Unity, if we click on our vehicle in the hierarchy, in the inspector, underneath the player controller script, you can actually see our speed variable now because it's public. And we can actually change the values however we want just by typing in any number. So I'll set this to 15, and then we'll press play. And you should see the car zip down the road. And a cool thing I can do, if I left click and drag on the speed variable on the word itself, if I drag it to the left, it actually brings it negative. So you can see it racing down the runway. Then if I bring it up, it goes up. And so this is a cool way to see exactly how fast you really want this vehicle to go. And then 5's kind of a good speed. Now let's make it to like 11 or so. 12, cool. Now when we stop playing, oh, our speed variable reset to 15. Well, if you remember, when we enter play mode, if we edit values, it'll reset those values when we exit to the way that it started when we were in our scene. So it actually set it back to 15. So we'll just bring this to like 10 for now. And then we'll save. A fun little tip for when you're programming, something that people commonly say whenever they create their variable, but then also assign it a value at the same time. This is called initializing a variable. And so we initialize the speed variable to be at 5.0 for its speed. So what you're going to do is you're going to create your very first variable so we can store the speed that we want our vehicle to move. Make sure that you use the keyword public so that way we can see this variable outside of this class and use it. Use the keyword float, that way we know that our speed variable is a number that uses decimals. We can choose what we want to name our variable, so we'll name it speed, and then we use the equal sign to assign or to set our speed to be 5, and then make sure if you use the .0 just to add an F at the end, so that way our program knows that this is a decimal number. And then in your update method, change the 20 to speed and test your game. And then while your game's playing, if you select the vehicle and then you go into play mode, you can actually left click on the speed under the player controller and drag it, and you can change the numbers by scrolling side to side. Now it's your turn.
Alrighty. Again, mistake. Boom. Let's go in here. I'm gonna go PUBLIC FL float speed equals 5.0 F com. It auto filled it in because that was a variable. That should not be capital. That should be fine, right? Alright, I think this is a good second live stream. I'm actually gonna take a break. After a while, this can get boring. I'm gonna like, take a 30-minute break and I'll be back. Probably if the turn to time, if I have dinner, because it's like 5 o'clock right now, I'll have dinner, and I'll come back later on. If you guys enjoyed the stream, thank you. I'll be back later, hopefully get some more progress done. But anyways, guys, hope you guys enjoyed this stream, and I'll see you guys in the next stream later.